So, good morning, everybody. This is morning in Chile. First, I want to thank Professor Masari Isora for his kind introduction words. We're friends and we're working together for several years. And he taught me much what I know about education, particularly math education and lesson study. I also would like to thank Professor Maitri Imprasita from Conferencia University that invited me to this talk. And also I learned a lot from the experience in Thailand that he has lived all these years. And also would like to thank to Marco Harula, who helped me review the manuscript. So what I'm going to talk today is what mathematical thinking skills will our citizens need in 20 more years to function effectively in a super smart society. So the big effort is to imagine the future. That's a logo that University of Tsukuba have. I've impressed me also a lot. So we have here the kids emerging to the future. And, so what is that they will need? I'm going to talk about two parts. The first part of my talk is about the challenges that I see, and the second, the solutions. So what are the challenges? In the first part about the challenges, I see four big challenges for the next 20 years. And there is particularly one that I think is more disruptive. That's AI in society. So it's like the second point would be how sourcing our thinking to intelligence applications, and this is going to have a big impact. Then I feel that in order to solve this, we have to consider we are in an evolutionary trap, and then we have to think how to escape from this trap. Our brain is very powerful, but it's adapted to another area, basically to the last 100,000 years that our ancestors lived. But it's not well adapted to today. And this challenge of AI and the big impact on society will need new way of thinking and collaborating. Then the solutions. I'm going to talk about what I think the solution is mathematical thinking skills, particularly modeling, and especially certain core set of models that our kids need to, in order to understand all these intelligent apps, understand how do they work. But also be creative, building new models. And then I'm going to talk about how to prepare our teacher to teach these new thinking skills and how to use technology to really form a super smart community of teachers. So the four challenges. The first challenge I see is important is the climate change. Here, these are the last 15,000 years of society, and this consuming energy per capita was very little, just food. But we have a peak here around the Roman Empire. And now it's much, much more, like 50 times what it used to be. So they consume energy per capita. And here are countries like Japan, US, Europe. And most of developing countries are around here. But all these countries want to leave us in the US, Japan, and Europe. So they will need much more energy. And much more energy means that CO2 will explode. So it's going to be a big impact. We have to work on energy efficiency. And this has a big impact like forest fires. We've seen these days in Canada and California. And this is in the National Congress in Chile. And we have this forest fire very close to our National Congress. So this is one of the big challenges that we have to consider when preparing our students for the next 20 years. The second is pandemics. Well, we have seen the big eruption the pandemic has produced on all of us, particularly because we have now society with high density, high mobility, and this produces more and more frequently will produce different kind of pandemics. So these are diseases completely different from the diseases we had before the agricultural revolution that are mainly produced by the density of the population. And so we need to prepare our students also with mathematical thinking skills in order to understand this phenomena and how to manage it the best way possible. The third is inequality. According to President Obama, this is the defining challenge of our time. And it's a big challenge because it has several angles. For example, here we have this graphic from Nobel laureate Sir Angus Deaton in the United States from 1990 to now, basically. And this is the expected years of life at 25 of the population that already have college studies, like Bachelor of Arts, and the ones that don't have Bachelor of Arts. We see a widening gap in how many just years of life from around 53 to around 59. You have to add this to the 25. So this is a big problem we have to face, and our students will have to face, and it has to do with innovation and adaptation to new technologies. So somehow this population have problem with that, and also with the some particular features of the digital economy, where the winner-take-all economy, like multimillionaires or John Lennon and the musician and players like Messi make a lot of money, and the rest of the soccer players may barely survive. Also, most of the musicians barely survive. And this is produced by the structure of the digital economy. So here we have a big challenge. And the fourth challenge is AI. I think this is the most important one because I like the three previous challenges. This challenge is a major turning point in the history of civilization. It means a completely new way of living and a completely different ecosystem. The autonomy, free will, and nature of the human condition are at stake. Machine can do everything for you, think for you, make decisions for you, and this has a big implication in all of us. And so I think this is the biggest challenge. I'm going to focus in this challenge. So this is outsourcing now your thinking skill to a concept of apps. Try to understand this phenomenon. What is this? We have a super smart society. Think that your smartphone talks to you and makes suggestions. That's already happening. Like Google Maps tell you how to go from point A to B. But not only that, it could be that take initiative with autonomous vehicles. The car will drive, and take you there, but also administer you drugs and a lot of things instead of you. So your smartphone, the device, an intelligent agent will do this for you. And not only that, but it started to learn autonomously faster than you, so understand what's going on around you much better, and understanding also yourself much better than yourself. That's what Araya says. This is also Professor Araya, historian from Israel, said this is a big challenge. Imagine also a second app in your smartphone that takes initiative but has another opinion different from you, from the previous one. So what are you going to do if you have two smart, one saying do this and the other saying do that? And maybe both sides will take the initiative to talk each other and discuss their arguments and maybe find an agreement, but you're going to be completely out of the equation. So you don't understand what's going on. And maybe you have 10 different apps with different personalities and making different decisions instead of you. So this is really a radically new world. And this is basically the super smart society. Fascinating world, but it could be very, very disruptive. You can think you as King Arthur, but now you have this counselor of apps that are making, suggesting the decision for you and making the decisions instead of you. And your main problem is the problem of trust. Whom to trust? Which of these apps you should trust? How do you decide what to trust? That, I think, is the main challenge we have. And now let's see if our brain is really adapted to this condition. We have to look the evolution of our brain. The evolutionary brain is well adapted to the recurrent problems that our ancestors have to solve the last hundreds, thousands, or millions of years. It's well adapted to that ecosystem. But now the ecosystem is changing very radically, and probably then it is not well adapted our brain to several of these. For example, a case of mismatch or trap is obesity. We like calories because in the typical conditions of our ancestors, food was not always available. It was not for sure if we're going to have food tomorrow. And we didn't have refrigerator to gather food and accumulate food. So if we have something that was give a lot of calories, we will eat it as much as possible today. So that's how our brain is adapted. But in the current situation that we can go to a supermarket and buy as much as we want, then this adaptation of our brain that was very powerful in those conditions, but now in the present condition leads to obesity, and it's very difficult to to try to change yourself and avoid obesity. So this is an example of maladaptation. Another example of maladaptation is what's called the Dunbar number. Our ancestors lived in small groups, small tribes, up to 150 people. That was called the Dunbar number. And that includes from babies to old people. And most of them were your relatives. So the trust problem was much simpler in the sense that you knew all of them are your relatives. And moreover, you currently, every day, you know each other, which is each one doing. Was a big, enormous step in the last 1,000 years to have societies with millions of people where most of the people you would encounter, you would never know before, and you will never know again. So this is completely different. And so our trust, we have to trust now in apps is another big change, because our brain is more adapted to face and trust in small groups. So we're adapted to small groups, but this is not a very simple thing, even for an app to compute and to understand what people are doing, because it's what is called in game theory a multiplayer pursuit and avoidance game. You have to think what other people are thinking about you and try to read their minds. So it's really an explosion of combinations. It's very difficult to compute what to do. That's why we have this limit. But apps and intelligent agents will have this limit also, this difficulty. But now we have not only us, each one of us with different apps that are suggesting us what to do and making decisions for us. But one of the problems that is compounded here is that there are other entities like organizations that are trying to influence these apps and you. And so some of these apps maybe are serving the interest of third parties, not your interest. So you think all these apps are helping you, but you have to consider some of them are helping other organizations, companies, and or the apps, other people. So it's really the trust problem is a major problem. We have to think how to handle this problem. What is the solution I see? I see that citizens will have to understand how these apps are made. What are the algorithms that they use? What are the big data that they're using to learn? Also the learning algorithms that they're using. And so once we understand roughly the computational ideas, the models that are behind this app, we will have a better possibility to know which one to trust. So that's the problem. The main problem that I see is the problem of trust. We have a society not only with millions of people, but with tens or more or hundreds of apps serving different interests. So how can we teach them, our students, a modeling and a core set of model that be able to understand what's going on. In modeling, I follow when Pollack says in teaching modeling, you have to take some models and that have been created and have been known to be successful, and the student have to study those models and understand what makes them work and think about what went into their creation and the way they were formulated and their success. I think it's very important to consider that models are somehow an accumulation of culture inside of each of these models. It's very difficult. You start from zero, and a student will start from zero modeling just in a couple of in a session, a couple of sessions, or in a year. So you understand the main models and what spaces. There is a core set of models that each one should know, and because it's somehow all these intelligence apps are based in this course or use some of this core set of models. So I think that our first mission to prepare our students is to think and devise strategies to select and teach a core set of models to our students. For example, for inequality, let's consider the Schelling segregation model. What we have been doing with students in elementary and high school is first learn to use the model, then select, and once you, as experts of engineers and scientists do, they work for years in one model and little by little start to select the different options of this model, then adjust this model a little bit, and finally, once you dominate well those models, you start to innovate and build new models. Here, for example, is a model. The world is this board. There is blue people and red people, and white means just spaces, and they are living in this world. And Schelling got the Nobel Prize in economy in part for this model, and the models that try to understand segregation. And see each one of these, like this one, this person here looks at his neighborhood, red, blue, 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 red. So if he see that in his neighborhood, most of them are a different color of him, then he would move at random and any place that is empty. That's the whole model. So there is something in us, I mean, it's true that we feel different from the rest, and we'll move from there. And then we get, after a while, we get this configuration because people start moving. And after a while, some iteration, we will get this. And you would see that then we have a segregation. So segregation in population is basically a product of very basic attitude or mental bag that we have. That is, if we are surrounded around people that are different, we will move. And this, so understanding this model of segregation, I think is very important in order to understand, for example, inequality. Why is this produced? But with this mechanism, we would get segregation in society. But it's very difficult that someone will just think on this model. Schelling was the first one to design and think and simplify the whole situation in this model. And for that, he got the Nobel Prize. So it's not that simple that everybody will just start on doing something like this. Here is a modern epidemiology. Again, this is a board. These balls represent people. And you see more density of people. You have more balls in this table. And you can model contagion when two of the balls will have a collision. Because with collision means the probability of contagion. But it's not only density. How would you model people having a mask, for example? So here's a model having a mask. So these people here don't have a mask, means people are at the center of this ball, but if they collision with the other, don't need to be very close because they are big radius. Here is people with mask, means that you have to very, very close to the other one in order to have a contagion. So this is a way of modeling. We are doing this with with elementary school kids, and they play with this model in a table with different balls. And also, it's important the mobility. Mobility means, okay, this moved in 4 units of time, and this is moved but much less in 4 units of time. And these are the trajectories. So somehow you could see here that you can use this model to make some prediction, and the model use density of the population, use or not of mass, and use the mobility, the velocity of the people in the society. So we think this is the kind of models that could be very attractive, and we need a core set of models that students will learn how to use, then little by little to select some of them, and then adjust those models to the situation they have in hands, particular situation, and then to innovate. So how is the innovation? Innovation is just the share of ideas. In yourself, you have different ideas, recombine ideas, as what Adam said, the mathematician Adam says, ideas rose in crowds. I felt them collide until pairs interlocked, so to speak, making stable combination. So finally, is a combination of ideas. Using all models, you will get combination of all models, get a new model. So, but also sharing ideas with other people. So it's something that our students will get to learn how to share ideas about the model, and with this recombine to new models. The other is an intentional state of mind. Is the work of Professor Masami Soda. I've been working in the important, and one of the things I learned from him, the importance of the attitude and character, and this intention attempting to make connections, exploring, looking for different alternatives, working to establish perspective, striving for counterexample, so on. So I think this is one of the key issues for the innovation is sharing with others, but the personal attitude. That's something we have to foster in our kids in order to have new models, improve the models that adapt better to the situation that we will have to face. But then we have to think how to prepare to teach you these thinking skills. I think this thinking skill model and have this core set of models is not something that we are now teaching. Is something that we're not putting much emphasis right now, and change to this new way of thinking and teach to that is going to be a big jump. And I think the solution for this is lesson study. For me, it was a cultural shock that, like 10 years ago, when I went to Japan, invited by Professor Soda and Professor Imprasida to Thailand to watch lesson study. It was very practical. Here you can see the students there. These are all teachers watching and taking notes of the lesson that is going on. For me, I was really impressed. Fortunately, I am tall and I could see what was going on. This is a picture I took. And this is a practical way to try innovation and see if they really work. And I think lesson study is the Japanese way of analyzing lesson, improving lesson. It's a way, it's a very powerful way to introduce new teaching practices. Here is in a school associated to Tsukuba. Here is a class, the lesson, and here is the teacher. There are maybe hundreds of teachers watching the lesson and following the plan of the lesson. And here they are projecting what is really going on, so everybody could see what they are doing. Is a zoom of what's going on. As I mentioned, this was a really cultural shock for me, completely different of the teacher development we have been doing in Chile and I've been seeing in other countries. And I saw the power of this to introduce innovation and building a community that behind this that is behind this process of innovating lessons. This is in Thailand, Ken. I was impressed because it was my first time I was named part of a panel to analyze the lesson. I had to mention that the teacher is Japanese and he's talking in Japanese, and the kids are Thai and talking in Thai, and it was a translator between Japanese and Thai, but I don't speak Japanese neither Thai, and I was a little bit nervous because we have to comment on what was going on. And then I realized that much of what's going on, I didn't need to understand exactly what they're saying. I could see the several other components, from gesture to body, non-verbal communication, the interest and the attitude of the students. So something that we had to consider in lesson study and that I haven't paid enough attention before. We have been doing this lesson studies. The case in Chile is the National Congress of Chile, and here is a lesson. The National Congress 2 years ago, and they allow us to make a lesson study and open lessons in the National Congress. So it's something that I think is spreading to several other countries, and it's a very powerful way to introduce innovation. So now I'm going to tell you about innovation that this APEC project has been doing, led by Professor Isora and Professor Impersita, and how we can, using this lesson study methodology, introduce new lessons, new way of teaching. So I'm going to show my experience doing forest fire modeling. So the kids learn to use the model, then adjust a little bit model, and then start changing this model. So this is a concrete model. You see the trees here, and you see the numbers that are behind. It's somehow the height of the trees. Like so, this model the kids will use. Here are kids in the garden of the school playing with this model. So so this is the way the kids are playing with the model. But little by little, they go to a more abstract model. Here, you see this in this place. The wall is now is a board. Here it starts the fire, and the next time, and this T equals 1. The next time, T equals 2. Where was the fire? It's already burned, and they spread the fire. So yes, this is a model. And then the next time, T equals 3, you have this is already burned, but now here the fire. And so the kids have to learn to work with this model, initially with a very concrete and similar to a first fire. And now we have this board here, we have 2 fires, and here is a house, and they have some control variables that are putting water in some place. Oh, these are controlled fires, so you can put a control fire somewhere, because once it's burned, the fire will not go through this part. So the students start using this kind of model, and here we see una situación en la que hay una casa como la que está allá abajo. Here is the house. Here's the fire, and here is student working on this more abstract model.
Quema controlada, ¿ya? O sea, en el momento inicial está así, el fuego comenzó allá. Sí. ¿Y qué pasaría en un momento después?
So they thinking, oh, here's already burned, and this is spread. So now the fire is being spread.
El fuego se propaga en todo alrededor. Se está llenando.
And here is spreading the fire,
¿Y qué hacen ustedes? Entonces,
and use a control variable. To protect the house, they are using this controlled fire. So that once this get into there, it's going to be already burned around the house. So these are elementary school students, 4th and 5th grade students working on this. So somehow capturing the idea of the model. So start using the model, playing with the model. And here is the same model being taught is in a school in Japan in grade 9, discussing the model. Here teachers from different parts of Japan and other countries. I'm teaching here the class with translator, these Lebanese students, and here this really is a computational model of a fire, the same as we have seen before, and burn. He says it's already burned. It's already burned. Burn. House. Yeah. And he is looking at the strategies. Well, so when we see with this experience of lesson study, that is a way to introduce radically new ideas in this case, computational thinking, mathematical thinking, and new and trying and ways to introduce this in the lessons. And what we do, and what was really impressed with this, is that it's a project that Professor Isoda and Professor Impresita have been leading, that introducing new ideas like these forest fires, and we have the plan is that every year, around 21 countries from the APEC, they agree in a problem that it's something completely new that we want to teach students, something applied like this forest fire problem, and then each country work on their schools how to introduce this, and about half a year later, we met together and they show videos of their lessons and have been working these ideas, and everybody shares ideas and make a combination of ideas, like Adamar said, and then after that, this feedback we work one more semester, again going back doing lesson study with different schools and students and teachers, and at the end of the process, one is selected, and in this case, it was I was selected to teach in Japan this complete new lesson, and this is the way to introduce completely new ideas in a community that will share all the ideas, and so this final lesson is a product, is a final product of the whole community that have been discussing this in parallel in different countries about how to introduce these new ideas. Well, so lesson study is very powerful, but we have some problems with lesson study that we would like to discuss. First, finding the time to meet face-to-face to observe lessons from other members of the group is not easy. We have been doing this, but it's always problem of time. The teachers have to go to other schools and watch what's going on, other teachers, other schools in the neighborhood. It works well with small group of teachers. Yeah, if they are from the same school, a big school is easier than a small school that you have to go to other places. Although open public lessons are developed with thousands of teachers actually watching the lesson, they take place only a couple of times a year. You cannot been doing this very, very, very frequently. And so this is the big lesson where you see a final product just a couple of times a year. And so what we need is build a much larger community, a more connected community, especially now that we have this big challenge for the next 20 years with AI, completely new way of thinking, this computational thinking with mathematical thinking and all these models. So how we do this, how we push this further in order to have more larger communities and working more frequently. That is that's the challenge. And otherwise, we could experience what is called the Tasmanian effect. Tasmanian effect because Tasmania, this island close to Australia, once the sea level rose like 10,000 or 50,000 years ago, what it was observed that the culture of Tasmanian people somehow decreased in the sense that the tools they use and different cultural tools regressed to much previous area, basically because they were disconnected, because there was a smaller number of people that could share ideas. So this is called the Tasmanian effect. And so in order to have a powerful community, we need size. So what I see now is a lesson study 2.0 with the area of technologies. Here is a lesson study, and with the tablet, you're at each point indicating what are the students and the kids doing according to certain protocol. And we use, for example, Corpus protocol, and then we have the time here, and the output that produced in this, we're using this device, is when the teacher is lecturing, which is asking open-ended question, when is writing, when doing experiment, what the teacher's moving around groups. So we have all this automatically being produced, and in this way, you maybe you don't need to have the other teachers from the other schools in your classroom. You can do it connected by internet and doing this categorizations of events in tablets. And using technology, for example, we see things like these are the number of seeking questions, student to student, student to teacher. So we have realized observing lessons using devices that students prefer in general to ask more questions to classmates and asking questions to teachers. It's something interesting. We realized that we discovered that it was 3-1 ask question to classmates versus ask question to teachers. We realized also that girls, females prefer ask question to females, males to males. These are fourth graders. So using technology, we can see it's like a new microscope to watch what's going on in the lessons. But not only that, you also using AI-based lesson study, we can analyze the discourse of the teacher, the acoustic features of the teacher, and transcriptions of what he's saying. Here, this is a teacher just using her smartphone, and from her smartphone produce load to the servers her speech, and from the speech the transcription of the class, and automatically analyze that. Also, we can see nonverbal behavior of the teacher, gestures, gaze, body orientation of the teacher. So using now apps, we can see, for example, here from the teacher has been talking in the lesson, her speech. We can see here is the moment where the teacher is presenting. This is the time from 0, 10, 20 minutes up to 1 hour. Here the teacher was presenting. And here is a predictor of the app. There are several predictors that we've been using, and it says the red means the app sync is presenting. Here the app sync is presenting as well. And this is when the teacher is guiding. This blue area is when it's guiding. Here is guiding as well. And these lines are different predictors that they're using that the apps have that's trying to predict when the teacher is really guiding. So you can have, just from the teacher's voice, you can have all this information automatically. And also from her voice, we can get transcription, and transcription somehow summarize the lesson. For example, this is a lesson we did in energy, and it was basically about energy, and there's more energy, and the energy and contamination and CO2. So that some of the core ideas that are behind. So also we can have automatic summarization of what's going on. And here is the gesture and gaze of the teacher, some students, and this is the body orientation of the teacher on real time. These are videos of that have been obtained with the teacher's smartphone, just the teacher's smartphone, not any special device. And we see here is another view of what's going on. So we can get all this information automatically, and so we can. The idea is in lesson study 2.0 is to use AI to analyze our lessons. So what I see is that we need to build a much larger and more connected community. And because the small community will have a transforming effect in a larger community, and with technology we can connect all of us and somehow solve this problem of not going to meet other other teachers in another schools. We can work connected and analyzing our lessons. So, as imagine the future to these kids, we have seen the challenges and the solution. I think the solution is a super smart lesson study community where all of us work together, and with technology we can build this super smart. This is one of our schools in the Cathedral of in Chile, and I see this as a metaphor that we have to build to the future. So we have to get up into this and help solve the problem. And solution is super smart lesson study community. Well, thank you very much.